In this video, we're going to talk about several different scenarios. We're going to look at objects moving in circles, and specifically, we're going to be talking about the object that's underlined and what's going on with that object. So we're going to look at, well, of the forces acting on that object that's underlined, are there any forces that are consistently acting in the centripetal direction, or in towards the center? Are there any forces that are acting consistently out from the center, or in the centrifugal direction? Or are there forces that are either not ever acting in those directions, or not consistently acting in those directions? We'll put them over here, and this is basically an other category. And just to keep in mind, these words centripetal and centrifugal, you want to really use those as describing directions, just like left, right, up, down, forward, backward. Centripetal and centrifugal are directions, and that's the best way to use them. Alright, let's start by watching a video of a ball on a string being spun in a circle.
Speed, but I'm changing its direction all the time.
Alright, so you got a chance to see the ball spinning in a circular path. And now let's look here at this circle representing the path of the ball. When it's at the top, well, what forces are acting on it? We've got the force of gravity acting downward, which is also called the weight. We've got tension acting downward. We've got the air resistance. Well, if it's going around in a clockwise manner, the air resistance would be going that way. And let's say if we get over to here, then we've got tension acting that way, weight this way, air resistance this way. Get down to the bottom. Oh, we can't really see that, but there's weight acting straight down. There's tension acting upward, air resistance. Alright, so let's see. Tension is always acting in towards the center. There's no force that's consistently acting out from the center. There's not any force here or here acting out from the center. Down here we do have weight that you can't really see, but that's none. And then we have the force of gravity, which is also called weight, or air resistance. Alright, and we didn't come up with anything for here. We'll leave that blank. And now let's move on to the moon orbiting the Earth. So, if this is the Earth here, and then the moon is right there. The moon is smaller than the Earth, and it's actually much farther away. This is not a scale drawing. But the moon's here, and then it's here, and then it's here, and so on. Well, what forces are acting on the moon? We've got the force of gravity. That's the Earth pulling on it. And that force is acting in towards the center. So the force of gravity of the Earth pulling on the moon. And we think about, well, what other forces are acting on the moon? Well, there's no air resistance. There's no normal force. It's not touching anything. There's no tension. There are forces of gravity from other objects, like the sun. So, force of gravity of the sun pulling on the moon. I should have explained it first, but let's imagine the sun is like over here somewhere. You can see it right at the edge of the screen. And the sun is gigantic, and you can only see just the very little bit of it. Of course, it would be much farther away. Well, the sun is pulling on it in a direction that, as we get over here, you can see it's not consistently inward and it's not consistently outward. Okay, and you might say, well, wait a minute, what about the force of the Earth? What about the force of the moon pulling on the Earth? This force. Moon pulling on Earth. Well, that's consistently outward. But that's a force of the moon pulling on the Earth. And remember, we're only analyzing the object that's underlined. So we're not analyzing the Earth here, we're analyzing the moon. And the force that's causing it to go in a circular path is the force of gravity of the Earth. Alright, next up is a person in a carnival ride. Let's take a look. Okay, so in the case of the Carnival ride, we could see people. We weren't quite looking from a top view, but let's think about a true top view. If we had a camera that was right over the top of the center, then we could look down and we would see somebody's head, and we would see their shoulders, just like that, and then they'd be over here, and we'd see their head, and we'd see their shoulders. There we go. You get the idea. So what are the forces acting in this case? Well, the force of gravity would be acting straight into the screen or the page, the way you're looking at it. And so that's the force of gravity. So that's not in towards the center or out from the center. So the force of gravity, or weight, neither one. The normal force would be coming right out of the screen at us. So that's neither one. Okay, that's the normal force from the what? From the floor. That's right, but there's another normal force there. That's the normal force from the wall. Normal force from the wall is consistently acting in towards the center. So normal force from the wall, and then, well, in this ride, if you've ever been in this ride, it certainly feels like you're getting pushed that way. But can you think of any actual forces that are acting in that direction? The answer is no. Okay, so centrifugal force, that's not a type of force. That's just a direction. So if we can't think of an actual force acting that way, we can't list it. All right, we've got one more. Okay, one more force, or one more scenario here. We're going to go ahead and take a look at a brief video of that. All right, so again, we're going to think about a top view of that ball and hoop. And as the ball goes around there, what's it touching as it does that? Well, it's touching the hoop itself, and the hoop is pushing it inward. And so this is very similar to our last one. So this is the normal force from the hoop. There's also a normal force from the table, and that's coming straight out at us, which is not in towards the center and not out from the center. So the normal force from the table is neither one. And then straight away from us, right into the screen, so to speak, would be the force of gravity, or weight. And then we could try to think of some other ones, like air resistance. Okay, that would be acting like that, so that would be in the neither column. And we could get into friction, but let's just leave that alone. It's not acting in the centripetal or centrifugal direction. So what should we get out of all this? Looking at the patterns here, we see there's always a force acting in the centripetal direction. And we also see that we had all those objects moving in a circular path, and we think, we feel like, especially like for a ride or being in a car, we feel like there should be a force in the centrifugal direction, but there's not any. Okay? There could be, but there doesn't have to be. And so the important thing to take away from this is for objects to move in a circular path, there has to be a force acting in the centripetal direction. Okay? For objects to move in a circular path, there has to be an inward force. And that inward force, we shouldn't really call it the centripetal force. I mean, that's generically what it is, but specifically we should be able to identify actual forces that we've already learned about, like tension, force of gravity, normal force, and so on. All right. Good luck on your rotational motion problems analyzing, and remember, you're always going to be able to find a force in the centripetal direction.